All right. To look at solving polynomial inequalities, we need to remember how to solve polynomial equations. Remember that if two things are going to multiply together to be 0, that means one of the two had to be 0. So we figure out what would make the first factor 0, so that would be x equals 0, and figure out what would make x minus 4 be 0. Well, this would, of course, is x equals 4. Now, what would make x times x minus 4 greater than 0? Well, we can use this idea of like a sign chart to help us. Here's our number line. We know that at 0 and at 4, that's when I am at 0. Let me mark those points there. Here's 0, and I guess this will be 4. Let's pick a number in this section and plug it in. Let's see what kind of number we get back out. Are we going to get a positive back out or a negative back out? So let's try, how about negative 2? If I plug in negative 2, I will get a negative number. If I plug in negative 2 here, negative 2 minus 4 is another negative number. A negative times a negative is going to give me a positive answer. So basically, any number over here, if I pick negative 8, I would have a negative and a negative. I'd end up with a positive answer. Now, what about between 0 and 4? We can pick any number in between there. So let's pick 2. That'd be 2, which is positive. When I plug in 2 here, 2 minus 4 is negative. A positive times a negative gives me a negative answer. Now let's try something further. What about something above 4? How about 6? Let's have a positive times a positive. I'll get a positive answer back. So now, what part of that number line gave me positive answers? Because that's what's greater than 0. Well, it's from negative infinity to 0. And then we have a break. And then we have from 4 to positive infinity. Well, let's change the problem around. What about what would make x minus 4 less than or equal to 0? Okay, so remember that would be negative numbers. And it would also be these points that make me be 0. So it's everything from 0 to 4, including 0 and 4. Let's look at another one. X minus 3 times x plus 4 times x minus 7 greater than or equal to 0. Okay, so we want to know our little boundary points, which would be our roots, our solutions there. So those zeros, or those boundary points, we've got negative 4, 3, and 7. Now if I choose a number less than negative 4 and plug it in, say negative 6. Negative 6 minus 3 would give me a negative answer. Negative 6 plus 4 is negative. Negative 6 minus 7 is negative. If I have a negative times another negative, I get a negative answer back. What about between negative 4 and 3? Ooh, how about 0? That's an easy one. 0 minus 3 is negative. 0 plus 4 is positive. 0 minus 7 is negative. That would give me a positive answer. What about between 3 and 7? Now let's pick 5. 5 minus 3 is positive. 5 plus 4 is positive. 5 minus 7 is negative. So I'd end up with a negative answer. Past 7, how about 10? 10 minus 3 is positive. 10 plus 4 is positive. 10 minus 7 is positive. I end up with a positive answer. So what values are going to give me greater than or equal to 0? Well, that's all the positives, and it's also all the points. So I need from negative 4 to 3, including those points. And then we want from 7 to positive infinity. Now, what I want you to relate this to is, let's think about the graphs. Let's think about the graph of this first one. X times x minus 4. We know these are our roots, our zeros. And this would be a quadratic. Means it starts up and ends up. Oh my gosh! It starts up, starts positive, and it ends up, it ends positive. Look at the way that graph would go. So where we would have gotten a positive answer from doing the sign chart, the graph is above the x-axis. Below the x-axis is where we got negatives. Above the x-axis is where we got positives. What about down here? This has 3 roots, or 3 zeros. So that means I have a cubic. Cubics, or odd functions, start at the bottom. So this one would have started down here, gone up, down, and up. So we could have actually just graphed this, figured out which parts are negative and positive, and been able to answer the question without having to plug in anything. Let's go to another one. What if I have number 5? X minus 2 squared. X. Oh, let's just do a hard one. 3 cubed and x minus 4. Less than 0. What's going to make that less than 0? So we're going to do a really hard one here. My roots. I have x equals 2, which is a double. I have negative 3, which is a triple. And I have 4, which is a single. So let's count up. That's 1, 2, 3, 4, 5, 6. That means our degree of our polynomial would be 6. That means it behaves kind of like x squared. It's going to start at the top and end at the top. But let's see what it does in the middle. My roots are, I've got negative 3, 2, and 4. It's even, so it starts at the top. At negative 3, a triple gets a stall out, as I like to call it. That means the graph comes down. It thinks about bouncing, but then it just bounces the other way. At 2, we have a double. Graph comes up, touches it, and turns right around. 4 is a single, so the graph is just going to go through 4. Now let's figure out which parts of our graph are positive or negative. This section of the graph is above, so that's all positive values. Between negative 3 and 2, our graph is below, so that's negative. Between 2 and 4, it's going to be negative, and from 4 up is going to be positive. Now we only want the parts that give us negative answers, but since it's not or equal to, we are not going to include the point. So that means I'm going to start at negative 3 and go to 2. And then we're going to start back up and talk about the section from 2 to 4.